For the last lesson of this unit, I want to go over some special factoring problems, ones that don't look like they should factor, but they actually do. So for instance, this one, there's 3 terms. What I want you to notice about the exponents of each of these terms is that the first exponent is twice as big as the middle. That means we can do quadratic factoring techniques on this to factor it. Now, before we do that, let's actually just do a little substitution. I'm going to go ahead and say y is equal to 5 to the x, so that middle term. If y is 5 to the x, that means y squared, so if I square it would be 5 to the 2x because you're squaring both sides. So I'm going to go ahead and do a substitution there. So we have y squared, because 5 to the 2x is y squared, plus y, because 5 to the x is y, minus 30, and I can go ahead and factor that. That should be pretty easy to factor. So factors of 30 are 6 and 5. If you do 6 minus 5, you get a 1. Select this middle term. So then I would just need to substitute back in, because you have to always go back to what the original variable was. So I'll just put 5 to the x in for these y's. And look at that. You have factored that problem. Okay, same idea with this next one. So this doesn't look like it should factor, but if you think about square root of x is the same thing as x to the 1/2 power. And this, just plain old x, is just x to the first. So 1 is twice as big as 1/2, which tells us we can actually factor this the quadratic way. So once again, if you need to, you actually don't need it if you can figure it out without it. But if you need to, make a little substitution, change your variable. So I might do y. And I usually pick the middle term. So I'm going to say y is the square root of x, which means y squared should just be x. And if I've picked my substitution correctly, I'll be able to get all the x's removed in the problem, and it should look like a pretty easy factoring problem. So y squared minus 7y minus 18. I'm going to go ahead and factor that. So that would be x, or y, oops, not a g, y minus 9, and then y plus 2. And then like I said on the previous problem, you always need to go back to what your original problem, the variable your original problem had. So I'm going to go ahead and replace this. This is square root of x minus 9, square root of x plus 2. And that's your final answer. Now, just as a side note, please don't say x is equal to square root of x. That's not true. That's why I pick a totally different variable. You can't say x is the same thing as the square root of x. That's only true if x equals 1 or if x equals 0, and we want this to be true for any x value. Okay? So always pick a different variable. You can choose z, w, whatever. Just don't use the same variable that was in the original problem. Okay, let's go ahead and do another one. All right. This looks nasty, which is super fun. So for this problem, it might be a good idea to first factor out your greatest common factor. And when you have a term at the very end for these weird factoring problems, I would call that your greatest common factor. Okay, whatever the exponent is on that. So we're actually going to go ahead and take out x to the negative 1/5 power. So x to the negative 1/5 power is what we're taking out. Now by doing that, I'm actually going to be dividing both terms by x to the negative 1/5. That's going to be important to figure out what that first term is. Our last term, it's the same thing, so it's just going to be minus 1. But for this first term, x to the 1/5 over x to the negative 1/5, when you are dividing just using exponential rules, when you're dividing, you're actually going to subtract those exponents. So it'll be x to the 1/5 minus 1, x to the 1/5 minus negative 1/5, which is the same thing as x to the 1/5 plus 1/5, which is 2/5, x to the 2/5. So this is the same thing as x to the 2/5 minus 1. This might be a good time to do a little substitution. We're not going to change the number out front. This will stay the same. But we need to factor this bad boy out. Okay? So I'm going to go ahead and say y is equal to x to the 1/5. We're going to do half that, and then say y squared is x to the 2/5. So I just double it. That way, if I do a substitution of just that just the highlighted part, we'd have y squared minus 1, which factors down to y minus 1 and then y plus 1. And then I can substitute the x to the 1/5 back into these y's to get my final answer of x to the 1/5 minus 1 and x to the 1/5 plus 1. It's kind of crazy, kind of fun. Let's do one more kind of fun one. Here's a double variable one. I'm actually not going to do a substitution for this. If there's a double variable and if it's squared on the first term and the last term, that just means your factors will have an x on the first term and a y on the last term, like the binomials. Okay, so let's actually just go ahead and figure out what x squared minus x minus 12 would factor to. So I'm ignoring the y's for a second. That would be the same thing as x minus 4x plus 3, because negative 4 plus 3 gives you a negative 1, but a negative 4 times 3 gives you a negative 12. So in order to do this problem, super easy, we just say x minus 4y and x plus 3y. And that's because if you multiply the 4y and the 3y together, you'll get this negative 12y squared. But then if you FOIL on the others, you can just double check, so you get a negative 4xy and a positive 3xy that you'd be adding together, and you'd get this negative xy and so on. So I'm just putting a y on the very last term for each part. And that's it. Special factoring problems, super cool. They don't come up super often, but they do come up.